Alright guys, this is going to be the first video for Mega CBA Review Day 1. So we're going to look at each of these and see how we can best get to the right answer. So, number 1. How many grams of hydrogen are found in 24.2 grams of C2H6? Well, anytime they are trying to find just a piece or just a element of a certain compound, we're doing a percent composition. So it's going to be important for us to find out how much of this mass comes from just hydrogen. Well, for us to do that first, we need to figure out how much hydrogen goes in just the molar mass of C2H6. So we're going to start to the side here. And if you remember when we did this, first we need to see how many of each element we have. So of carbon we have 2, and hydrogen we have 6. And what we need to do now is multiply them by their molar masses, which of course we can always find on the periodic table. So we find carbon's at about 12.01, so we'll multiply carbon by 12.01, and hydrogen is 1.01. Multiplying those out, we get 24.02 and 6.06. After we do that, we just add those together and we get 30.08. Just like how when we always find the molar mass. Now the thing is, we're not really bothered by carbon right now. We're not really worried about it. We're worried about hydrogen. So if we wanted to create a percentage for it, we would take part over whole, ditch this pen, do part over whole. So the part we're looking at right now is hydrogen, which we have 6.06 grams of hydrogen and 30.08 grams of dicarbon hexahydride. Now we could go through that and actually calculate the percentage, but we don't really need that. What we're looking for is how many grams of hydrogen are in 24.2 grams of dicarbon hexahydride. So we can actually just do a regular train track out of this. So as with all train tracks, we're going to start off with what we're given. So we begin with 24.2 grams of C2H6. Notice how I'm always including a unit and a compound, just like you should always do. Well, because we have grams of C2H6 on top in this step, that means we need to have grams of C2H6 on the bottom, so we can cancel that out. And we've actually already found the molar mass of this, because that's what you always do when you see the grams. So we're going to go ahead and put this 30.08 in front of grams here. So now the idea is we want to convert everything to grams of hydrogen. That's our goal. Well, we're usually not allowed to go from grams of one thing to grams of another. But we've already calculated how many grams of hydrogen are in this many grams of C2H6. And if we look over here, we've actually already made a conversion factor. This literally tells us every 6.02 grams of hydrogen can make 30.08 grams of C2H6. So we can plug this in right here. Grams of hydrogen are what we want to go to. And we saw that in C2H6 we always get 6.06 grams of hydrogen. So we plug that in there. Grams cancel out. Now we're going to multiply across, divide down. So we get 24.2 times 6.06 divided by 30.08. That totals out to 4.88 don't forget your unit, grams of hydrogen. That's going to be our final answer for that. That's telling us that in 24.2 grams of C2H6, 4.88 grams of that comes from hydrogen. Everything else comes from carbon. Alright, number 2. A lot of us kind of overthinking this one when we first started it. Basically, they're giving us a mass of an unknown subject, and they're telling us how many moles of it we have. Well, guys, when we're using the periodic table, the thing that we're looking up the most is generally the molar mass. And molar mass has a unit of grams per mole. That means on the periodic table, everything we look at on the bottom is telling us how many grams are in 1 mole of substance. Well, this question is showing us that 3 moles of this unknown substance weighs 84.258 grams. All we have to do here is figure out how much 1 mole weighs. So we have 84.258 grams over 3 moles. When we type that in, we get a total of 28.086 grams per mole. Now all we need to do is find a element that has that same amount for its molar mass. So we look across, generally it goes up as you go from left to right. So we look, and there we have silicon. So silicon has a mass of 28.085 on the periodic table, and that's pretty close to what we got. So we can assume that the element in question is silicon. Number 3 here. What is the mass of 7.5 moles of sodium chloride? This should be easy for us at this point. So I'm going to start off and do every step of the way, just in case you might have forgot something along the way. But what we have here is a molar conversion. We have moles of sodium chloride, and we want to go to mass, which we know mass, the unit for that is grams. So if we are doing mole maps like we've done from the beginning, for NaCl, we only need 1 because there's only 1 compound in question. So we're starting off with moles, that's what they're giving us, and they want us to go to grams. That should only take us 1 step. So when we draw a train track, we only have 1 vertical line. So as with any train track, we're going to begin with what they gave us on the top left. So we started with 7.5 moles of sodium chloride NaCl. Whatever's on the top goes to the bottom. And because on our map here we're going from moles to grams, the next thing on top is going to be grams of NaCl. Now, according to our rules, anytime we see moles, if it's not moles over moles, we put a 1 in front of it. In grams, anytime you see grams, we need to find the molar mass of whatever is following it. So, just like up here, we only have 1 sodium and we have 1 chlorine. Sodium is 22.99 grams per mole, and chlorine is 35.45 grams per mole. This is on the periodic table, but the sooner you memorize stuff like this, the faster you can do these problems. So we add that up and we should get 58.44 grams. So that's what's going to go in for sodium chloride here. 58.44 grams over 1 mole. Again, we multiply it out, so it should just be simply 7.5 times 58.44, and that would give us 438.3 grams of NaCl. If you're ever not sure of your unit, guys, you can always go back and cancel out anything that needs to be canceled out. Number 4. How many moles are there in 6.40 grams of ammonia? So another conversion question. Ammonia. First thing you got to know, guys, is what is the formula for ammonia. Now, it's not something that we've used a whole lot, but it should be something that you memorize. We have to be careful not to confuse that with ammonium, which on the back of our periodic table shows us we have NH4 with a positive charge. That's not what we're talking about here. For ammonia, you have to take away one of the hydrogens, and we get NH3, and there's no charge. So let's start off with that. We've got ammonia for our mole map here. We're starting off with grams, and we want to go to moles here. So this is going to be just another one-step train track. So draw your train track, one line up and down. Begin with 6.40 grams of NH3. Said we were going from grams to moles, so on the top here is going to be moles of NH3. Down here is going to be grams of NH3. Put your 1. Molar mass of NH3. Nitrogen weighs 14.01. Hydrogen weighs 1.01. We add all those together, we should get 17.04. It should be easy for us to find the molar mass of things like this by now. So now all we got to do, cancel out our units here. We know we're left with moles of ammonia. 6.04 times 1. 6.4 times 1 divided by 17.04. Our answer should come out to 0.376 moles of ammonia. Now I used 3 digits here in our answer because we have 3 significant digits in the question. Number 5, how many molecules were formula units? Now guys, formula units can be molecules, atoms, ions. It's just depending on what we're talking about in the question. So formula units for NaCl is going to be a molecule. So how many formula units are in 7.2 grams of sodium chloride? We've got another conversion, but this time we're going to molecules from grams. Now this is one of those where you can't do it in one step. We're beginning at grams here, and we want to go to molecules. Well, we can't go directly from here to here, so first we got to convert to moles, and then we're going to convert to molecules. So our train track this time has 2 steps. So we're going to draw 2 lines on this. We begin with 7.2 grams of NaCl. After that, we jump to moles of NaCl, and then we went to molecules of NaCl. I realize we can't see that. Go ahead and transfer your units down to the bottom. Grams of NaCl moves down here, and moles of NaCl is down here. So let's go through and distribute our numbers. Anytime you see moles, we get a 1. We've actually already calculated the molar mass of NaCl. We actually did that right here. So I'm going to go ahead and plug that number in front of grams. 58.44 grams of NaCl. And in front of molecules, if you remember, that's that huge number. That's Avogadro's number. We put in 6.02 times 10 to the 23rd molecules. Now guys, when you're plugging this in the calculator, make sure you put everything in parentheses where it needs to be in parentheses. You don't want to get all of this set up right and then mess up your number because you can't punch it in a calculator correctly. So multiply across, we got 7.2 times 6.02 times 10 to the 23rd. And we're going to divide that by 58.44. Your number should come out to 7.4 times 10 to the 22nd power molecules NaCl. Alright, last one for this page. What is the mass of 3.6 times 10 to the 24 molecules of water? Another conversion, and again it should be 2 steps. So do our map just to be safe here. We begin with molecules. Our goal is to get to mass. So 2 steps here. Train track has 2 lines on it. We begin with 3.6 times 10 to the 24 molecules of water, H2O. We went from molecules to moles. Again, every time I'm writing a unit and a compound. And then we're finally landing on grams of H2O. Bring down your units. Moles gets a 1. Molecules gets Avogadro's number, 6.02 times 10 to the 23rd. Grams, we should know the mass of water by now. It's 18.02. Plug everything into the calculator. Now, in this case, if you don't use parentheses around this number in particular, you're going to have problems. You're going to end up with some crazy high number. You don't really want a big exponent on this number, because these are pretty much canceling each other out. So make sure you use parentheses as you plug this in. We have 3.6 times 10 to the 24th times 18.02 divided by 6.02. Times 10 to the 23rd. Now, if you plug that in correctly, you should come out with about 110 grams of H2O. Now, my actual number that I got was 107.64, and that's fine, but if I'm using the proper number of significant digits, it would just be 2. So we have 110 grams of water. Alright guys, that's it for this page. We're going to do a couple more later.